It's hard to believe, but the Pacific coast may not be as calm as it looks. From Alaska to California, dormant volcanoes are stirring, and scientists warn a new wave of eruptions could be coming.
Well, one of the most active volcanoes in the world sits just a few hundred miles off the US West Coast, and some scientists believe that it's really only a matter of time before it erupts again.
From Alaska's frozen islands to California's scorched deserts, something ancient is stirring beneath the Earth's crust. Dormant volcanoes are rumbling. Ground sensors are detecting deep tremors, and scientists warn this could be the start of a new volcanic awakening across the western edge of the continent. For years, the Pacific coast was seen as a region of breathtaking beauty, a land of glaciers, redwoods, and endless ocean horizons. But what if that beauty was only a disguise? What if the very mountains we've admired for centuries are masks, hiding a chain of sleeping giants, ready to rise again? In the past 24 months, more than 2,000 small earthquakes have been recorded along the Cascadia subduction zone, the invisible fault line connecting Alaska, Canada, and the US Pacific Northwest. Deep underground, sensors detect strange patterns, harmonic tremors, the rhythmic quakes that often precede magma movement. Gas emissions are increasing in areas once thought extinct, while satellite data reveals ground deformation, mountains swelling, valleys lifting, and the Earth itself shifting like a creature stirring from sleep. In Alaska, Augustine volcano is exhaling sulfur into the air. In Oregon, the ground around the Three Sisters is rising like a balloon. In California, magma is pooling again beneath the massive Long Valley caldera. Scientists call these coincidences regional unrest. But what if they're not coincidences at all? Could the entire western edge of the continent, from Anchorage to San Diego, be part of a single connected awakening? Could the Pacific coast's serene silence be the calm before a chain reaction that reshapes the map itself? If nature is truly preparing to move again, then the question isn't where the first eruption will happen, it's when. Chapter 1. The chain reaction. Are the West Coast volcanoes connected? What if what's happening in Alaska isn't isolated at all? What if the same pulse of magma moving beneath Augustine and Spur is part of something far larger, something connecting the entire Pacific coast in ways we're only beginning to understand? Over the past year, seismologists from the US Geological Survey and the Canadian Geological Survey have noticed a pattern that's too consistent to ignore. The tremors beneath Alaska, British Columbia, Washington, Oregon, and Northern California are all occurring in a timed sequence, like a heartbeat traveling south. The signals repeat every few weeks, with each event slightly deeper than the last. It's as if the entire edge of the continent is breathing in perfect rhythm. Satellite radar interferometry, in SAR, shows synchronized ground deformation across thousands of kilometers, uplift in Alaska, subtle bulging in Oregon's Three Sisters, and minor subsidence near California's Long Valley caldera. These regions have no direct tectonic connection, yet the timing is undeniable. Scientists are calling it a lithospheric resonance, a chain reaction caused by deep pressure shifts at the base of the crust, perhaps triggered by the slow descent of the Pacific plate beneath North America. The scariest part? This kind of continental scale pattern has only been seen before in the months leading up to mega eruption events, like the ones that shaped Yellowstone's caldera or the Toba super eruption 74,000 years ago. So here's the terrifying question. Could the entire Pacific margin, from the Aleutians to California's deserts, be aligning for a single geological event? Or are these volcanoes communicating in a language older than time itself, warning us that the Earth's next great transformation has already begun, and that we're standing on the fault line of something far beyond our control? Chapter 2. The awakening beneath Alaska. The ground starts to breathe. It's hard to believe, but the ground beneath Alaska, one of the most remote and rugged places on Earth, seems to be alive. For months now, sensors from the Alaska Volcano Observatory, AVO, have been lighting up with data that defies logic. Hundreds of low-frequency quakes, deep, rhythmic, and pulsing, echo beneath the Aleutian Arc. At first, scientists thought it was normal tectonic movement, but then the frequencies changed. The vibrations began to oscillate in perfect intervals, something more akin to sound waves than earthquakes. Even more unnerving, the vibrations are traveling east, toward mainland Alaska. Instruments near Anchorage, Cook Inlet, and the Wrangell Mountains are now picking up microtremors with identical spectral patterns, a signature that matches volcanic resonance, not plate movement. Satellite imagery shows strange thermal anomalies spreading like veins of light beneath the snow. Near Augustine, the ice is melting in geometric lines. Near Mount Spur, small fissures are appearing in areas untouched for centuries. A pilot flying over the region in early spring reported seeing faint glows through the ice, like fireflies under glass. Geophysicists are divided. Some argue this could be a massive recharge of the Aleutian magma corridor, a network connecting volcanoes beneath the seafloor to continental Alaska. Others fear it's something else entirely, a slow build of crustal pressure that could trigger a cascade of eruptions if released at once. If that theory is true, then the Aleutian chain isn't a collection of separate volcanoes. It's a single enormous system, a supervolcanic organism stretching for more than 1,200 miles. And here's the chilling question no one wants to ask out loud. What happens if this vast system reaches critical pressure all at once? Would we see isolated eruptions, or a chain reaction powerful enough to alter the Pacific atmosphere itself? Chapter 3. The Cascadia connection. Is the Pacific Northwest starting to crack? What if the next great eruption isn't in Alaska, but right here, beneath the forests and cities of the Pacific Northwest? For years, scientists have warned about the Cascadia subduction zone, the hidden fault stretching from Vancouver Island to Northern California. It's capable of producing magnitude 9.0 earthquakes, tsunamis, and catastrophic ground uplift. But now, new data suggests the danger may be even greater than anyone thought. In early 2025, seismometers across Washington and Oregon began recording synchronized tremor bursts, thousands of tiny earthquakes humming beneath the crust. These weren't the sharp jolts of normal tectonic stress. They were slow quakes, lasting minutes or even hours, rippling silently through the earth. What's shocking is how regularly they occur, every 14 to 18 months, like the planet's own heartbeat. USGS researchers have now discovered that these pulses coincide with ground swelling near major volcanoes such as Mount Rainier, Mount Hood, and the Three Sisters. GPS sensors detect subtle vertical movement, centimeters at a time, but across hundreds of kilometers, that's a massive volume of displaced rock. The only explanation? Magma is moving, rising from deep reservoirs toward the crust. Even more unsettling are the gas emissions. Instruments have recorded spikes in carbon dioxide and sulfur dioxide from vents around Rainier and Hood. These gases don't appear unless magma is rising. Combined with tremor activity, this points to something brewing beneath the entire Cascadia corridor. Some scientists now fear that Cascadia is behaving less like a fault and more like a pressurized volcanic system. One geologist described it as a living wound, where tectonic plates and magma chambers are beginning to overlap. If true, this would mean the Pacific Northwest is entering a new geological phase, one where earthquakes and eruptions could feed into each other, amplifying destruction. So the question stands, could the next big one along Cascadia come not from shifting plates? Chapter 4. The Oregon Pressure Zone. Volcanoes on the rise. What if Oregon's peaceful mountain ranges are not dormant peaks, but but pressure valves getting ready to blow. In 2024, researchers from the University of Oregon made a stunning discovery. Beneath a 30-mile stretch between Mount Jefferson and the Three Sisters, seismic sensors detected a massive pocket of magma slowly rising through the crust. It's not molten yet, but it's hot enough to deform the ground above it. Satellite radar confirms the region is bulging upward at alarming speed. In some areas, the land is lifting by more than 3 centimeters a year, a geological blink of an eye. The USGS calls this the most significant uplift event in Oregon since modern records began. At the same time, a swarm of more than 240 earthquakes rattled the region over just 6 weeks. Most were small, but their pattern was unmistakable. The quakes formed a ring, outlining what scientists believe is a new magma intrusion zone. It's as if something enormous is pushing its way upward, reshaping the land in real time. Geochemical surveys tell an even darker story. Hot springs and groundwater near the uplift zone now contain elevated levels of helium-3, a gas that comes directly from the mantle. That means the system isn't just heating, it's actively feeding from below. Locals in Bend and Sisters, Oregon, say they've noticed strange new vents forming in the forest. Steam rising from fissures where the ground used to be solid. The entire Cascade Range seems to be breathing, its magma chambers adjusting, expanding, preparing. Could Oregon's gentle peaks, Jefferson, South Sister, and Broken Top, be part of the next major eruption cycle in North America? And if magma is already rising beneath the surface, how long before Oregon's forests and towns realize they're standing on a ticking clock? Chapter 5. California's hidden heat, when the ground starts to swell. It's hard to believe, but California's greatest danger might not be the San Andreas Fault. It could be what's quietly building pressure beneath it. In early 2025, geologists from the USGS Volcano Hazards Program reported something extraordinary. Satellite interferometry showed ground uplift across multiple volcanic sites, from Mount Shasta in the north to the Salton Buttes near the Mexican border. What was once thought to be minor geothermal expansion now looks like a massive reawakening of California's volcanic system. At Long Valley Caldera, one of the largest active volcanic depressions on Earth, the ground is rising again. New cracks have appeared near the town of Mammoth Lakes, and CO2 emissions have tripled since last spring. Tourists walking near Hot Creek report bubbles breaking through the surface, gas pockets escaping from magma less than 5 miles below. Scientists confirm that the caldera is refilling, slowly but surely. Further south, the Salton Buttes, 5 lava domes near the Salton Sea, are showing spikes in CO2 and hydrogen sulfide. Seismic activity is up nearly 400% since last year, and deep harmonic tremors, the same kind that preceded Mount St. Helens' 1980 eruption, have been recorded beneath the site. In Northern California, Mount Shasta's slopes are warming too. Thermal cameras reveal faint hotspots emerging beneath the snow, and new fumaroles have appeared along its ridges. A geologist studying the data described it as a pulse running through the spine of California. The findings have sparked a chilling question among experts. What if the state's volcanoes aren't isolated, but part of one massive, connected magma corridor running parallel to the San Andreas Fault? If that's true, California's geological clock may already be ticking. And when magma and tectonics align, history shows the result is never gentle. Chapter 6. The silent corridor. Is magma moving beneath the entire west coast? What if every tremor we've seen, from Alaska to California, is part of the same event, building in secret beneath our feet? For decades, geologists believed the volcanoes of the west coast were isolated systems, each powered by their own magma reservoirs. But new 3D seismic imaging tells a far more unsettling story. Beneath the entire region lies a continuous network of molten pathways, stretching like fiery veins through the crust. This so-called Western Magma Corridor begins deep beneath the Aleutian Arc, snakes through Alaska's volcanic belt, crosses the Cascadia subduction zone, and appears to extend as far south as Southern California. In short, every major volcano west of the Rockies may be connected. In 2025, a team from Stanford and the University of British Columbia used seismic tomography, a geological ultrasound, to map these underground structures. What they found shocked even veteran scientists. A vast magma reservoir spanning nearly 2,000 kilometers appears to be breathing, expanding in pulses roughly every 6 to 8 months. Each pulse corresponds with real-world phenomena: ground uplift in Oregon, gas emissions in Washington, tremors in Alaska, and subsurface heating in California. The Earth, it seems, is coordinating its own movement. Researchers suspect this might be part of a continental-scale mantle surge, where rising magma redistributes pressure along fault zones. If that's true, then the Pacific Coast's volcanoes aren't just waking up, they're communicating. The implications are staggering. One shift in pressure could trigger multiple eruptions across state lines, overwhelming monitoring systems and evacuation protocols. The last time something similar occurred was nearly 10,000 years ago, and it reshaped half the planet's atmosphere. So what if this isn't a coincidence? What if the planet itself is realigning, one pulse at a time, preparing for a chain reaction we can't yet predict or stop? And if the entire corridor ignites at once, how much time would we have before the sky itself turns red?
Chapter 7. When the fire meets the fault. The final warning beneath the west. It's hard to imagine, but the most dangerous point in this entire chain may not be the volcanoes at all. It's where magma meets the San Andreas Fault. For decades, the San Andreas has been viewed purely as an earthquake hazard, a tectonic boundary slicing through California where the Pacific and North American plates grind endlessly against each other. But recent ground imaging reveals something no one expected: thermal anomalies along fault segments that should be cold. The crust is warming. In early 2025, researchers at Caltech and the USGS discovered a zone of superheated rock nearly 8 miles below the southern fault line, exactly beneath the Salton Sea region, where the fault and the magma corridor converge. The data suggests that magma is now pushing closer to the surface there than at any time in recorded history. Microquakes, thousands of them, have rippled through the area, forming a perfect linear pattern along the fault's base. They're not random, they're systematic, moving like dominoes along the plate boundary. If magma intrusion continues, the pressure could weaken the San Andreas from below, setting the stage for a dual catastrophe: an eruption and a megaquake striking together. It's the kind of event scientists call a cascading failure, when one natural system triggers another and control is lost. The last time this type of sequence was recorded on Earth was during the 1815 Tambora eruption, which altered global climate for years. Now, experts fear the Pacific coast could be on the verge of something similar, but far worse, given the scale of population and infrastructure. So the question stands: what happens when the fault that built California meets the fire rising beneath it? Could the big one we've all been warned about actually come from below, riding the same molten wave that's already stirring from Alaska to Mexico? And if this chain reaction begins, would we even see it coming? Chapter 8. The West awakens. The fire beneath us. It's hard to believe, but everything we thought we knew about the stability of the American West might be wrong. From Alaska's trembling coasts to California's restless mountains, a single message echoes beneath the surface: the Earth is stirring. Over the past 2 years, scientists have documented a chain of anomalies too synchronized to ignore. Magma corridors heating in unison, fault lines humming at identical frequencies, gases venting across thousands of miles,
and pulses of seismic activity aligning almost perfectly from the Aleutians to Baja California. Each tremor feels like a syllable in a message we haven't yet learned to translate. In remote observatories, researchers are beginning to admit what few dared to say aloud, that the entire Pacific edge of North America may be preparing for a unified geological event. Whether it's a cascade of eruptions, a megathrust quake, or something entirely new, no one knows for sure. What they do know is that the planet is evolving beneath us, breathing, shifting, aligning. Thermal imaging shows magma rising closer to the crust than at any point in modern records. Pressure readings across volcanic belts have surged simultaneously, and the San Andreas Fault now registers electromagnetic signatures once thought impossible in tectonic zones. The West is no longer quiet. It's whispering, waiting, and watching. And so we face the question that has haunted civilizations for centuries. What happens when the fire beneath finally meets the world we've built above it? Will we witness a rebirth of the continent or the beginning of its unraveling? If this story opened your eyes to what's really happening beneath the West Coast, don't look away now. Subscribe, turn on notifications, and join us as we uncover the hidden forces reshaping our planet. One tremor, one eruption, one awakening at a time. Because the next pulse of the Earth might already be on its way.